I now present to you Dr. Dave Chadee.
After that, I have to really, I can't go into any more detail. So all protocols observed. So we can move on. Okay, and in 2013, at the Answer McCall Awards, I actually outlined the role of scientists and science in society. But today I wish to actually discuss how the data, maybe you want to turn the chairs around? So today I wish to discuss how the data or the information or evidence that is gleaned from the research, how is it used by society? How and what role does it play in planning of interventions? The theoretical concepts of which most people are accustomed to is that you need to have evidence for policy, and then policy informs planning, and planning leads to intervention. Is that model being followed? And is this a true reflection of the decision-making process? And how can international policies affect small island states? So this evening, the concept, we will examine how infectious diseases are imported into small islands. We will examine the triggers, and we need to be very careful that these triggers are fleas, not mites, and they are very common along the beach from Point Forte to Icacos. Ebola, we'll do a very brief discussion of Ebola. Then we'll talk about chikungunya and dengue. I know that's what most people would like to hear. But before we go there, I'd like to just talk about historically, when we look at diseases, we generally talk about diseases with respect to importing diseases. The only disease that has been exported from the Caribbean region is the chigo flea, or tungiasis, or the older folk would remember jiggers. And this was first found in Haiti by Vidal on board the ship, the Santa Maria, that ran aground in Haiti. This subsequently got spread to other parts of the world. And it's interesting that the transportation mechanism, during the Middle Passage, they transported the human cargo, but to balance the boats that were going back for human cargo, they actually took the sand from the coastline for ballast so that the ships would not tilt over. And as a result, when they got to port in Europe or in Africa, they just simply dumped the sand out. And these sand banks essentially were infested with the chigo flea, and it led to the invasion of the flea, Tunga penetrans, into Africa, and it made its way into Europe and has gone as far as New Zealand and Australia. And one of the reasons why I've put those sexy legs there is exactly the reason very many tourists come to the Caribbean and to some parts of Brazil, and they go on the beach and they sunbathe without using a towel or some protective coating between the cells and the sand. And as a result, that person was infected with the Tunga penetrans. So the foot there is actually one of a fisherman from Icacos in Trinidad. So what we have now gone through by that example is that diseases have its geographic spread, and there are different mechanisms for it. It first has to arrive, like this in the sand in Africa and in Europe, but it has to be established. It must establish itself. It must infect people. And therefore, people then would have to spread it to other parts of the world or the other parts of the country. Next slide. So this is really the basis for disease transmission. And so therefore what do we need is a suitable environment. The environment that we need is it conducive for the growth of vectors? Is it suitable for the chigo flea? Is it suitable for a virus to be released? So the environment is very important. And in the dengue business, we would be talking about the vector Aedes aegypti. Also, the presence of the pathogen. We need the pathogen or the disease agent for it to be transmitted. So you cannot have transmission if you have the vector and you don't have the pathogen. The third is the density. A large number of agents have to be accumulated. A number of mosquitoes, for example, would have to be infected, and they must survive long enough for the virus to actually replicate, to multiply before the insect become infectious. So if the insect become infectious and your population is immunologically naive, that means they have never experienced or been exposed to that virus, they would all become infected. However, if you have available vaccines, like in the yellow fever situation, there will be no transmission of the disease. So that's why very often you see on the newspapers, people are talking about the development of vaccines for dengue, for malaria, and for other diseases. But important here is the role of reservoirs. And this is something that we're going to touch on this afternoon or this evening. If we look at the history of the disease, we would see yellow fever and chikungunya actually originating in Africa. And it's spreading up to the west coast, to the east coast, and coming down to South Africa. And this made its way into Brazil. It infected the red howler monkeys, and these red howler monkeys were very susceptible, but they became good reservoirs because they did not die of the infection. And so one of the residues of that human trafficking that took place in the Middle Passage is the transportation of the yellow fever virus to the West Indies. There is also, and we all know about dengue. The origin of dengue is from Southeast Asia. And you can see it has made its way into Africa, and from Africa to the Caribbean. Let's look at chikungunya. Chikungunya also started in Africa. It made its way to the islands in the Indian Ocean, to India, and then to Southeast Asia, and then went to Europe. And from Europe, chikungunya then came down to the Caribbean, with the first infection occurring in Saint Martin, then the French islands of Martinique and Guadeloupe, and then Curacao, Aruba, and then it's now spread like wildfire throughout the region. So there seems to be an association between the movement of disease by the whatever mechanism there is, whether it's by boat or by aircraft. Next slide. So what is this telling us? Is that what models can we use? Can we use a policy and planning model to handle these diseases? Or do we just say it's globalization? So how do we come to policy and planning? And I heard the minister actually talking about policy and planning. Next, please. The way we know it in public health is that evidence is used to inform policy. Policy is then used for planning, and planning for implementation. Globalization, on the other hand, is the process of international integration arising from the interchange of the worldview, culture, ideas, and everything else that must be taken into consideration. So essentially, globalization has made us into a global village where there is a clean interaction between everybody. So we are now a global village. Well, can anybody tell me what this object is? Don't bother. It's not a meteorite, okay? And it's not what they landed on the comet. It is the Caribbean region and the flights that come into the Caribbean region. Next, please. This is the flight path to North America and in our region. So this is really a representation of what is happening in the world. Every day, 27,000 flights take off and land in the United States. That's only in the United States. And all the others are from other parts of the world, which we will see. Now, there is something instructive about chaos. That looks like utter chaos, but we all survive these flights. And out of that chaos comes that we are able to use that information for people who move from one point to the next. So people can be moved, animals can be moved, viruses could be moved, and more importantly, diseased animals could be transported. So any and everything could be transported using this flight path. And therefore, the region is therefore susceptible. So if we just look at the world, looking at about 5 or 6 different airlines, you would see it literally lights up the sky. And the strange thing is China has decided that they are going to develop 92 new airports within the next 12 years. So the sky will be even worse. Because of the flight arrangements and because of the flight paths, we are now in the midst of very exciting times. And for the public health practitioner, you can't ask for more. There's Ebola, there's chikungunya, and there's our good old faithful dengue. What more do you want as a practitioner? It's excitement every day. Next, please. For Ebola, this is what the virus looks like. Next, please. Ebola was first discovered in the Ebola River, which was part of the Democratic Republic of Congo, and therefore it was given the name Ebola. The important thing here, there are non-human primates like gorillas and chimpanzees that are associated with the virus, and therefore they serve as good reservoirs. And remember, I was telling you when I outlined the number of factors for transmission, I spoke about the role of reservoirs. There are 5 different strains of the Ebola virus, 4 of which are infectious to man, and 1 that is restricted to primates. Next, please. This rhesus monkey is thought to be the reservoir of the Ebola virus. Next. The second thing is that we need to know is that bats are dangerous delicacies in the region. Lots of people eat bats, and they use it, they dry it, and they use it for soup. The part of the problem with bats is that while you are handling the bat, you are therefore exposed to the virus. And so just the butchery alone of the bats will create problems. These are what they look like. Very cute looking things, but now with respect to the transmission pattern, you know, nature has a way of actually minding its own business. And it minds its own business, but when other people get into nature's business, we have a problem. So Ebola was being transmitted from the bats to the animals in the forest without any problems. But as soon as we started encroaching on the environment, we started changing the dynamics of the disease. So the bats all of a sudden had another a primate, a deer, but also can mistake the primate for humans, and then transmission occurs to humans. And we know that transmission from human to human can occur as a result of the exchange of body fluids. What is interesting is today, in today's Guardian, they actually found an Indian national who was infected in Liberia, who was cleared of the infection, but still had Ebola virus in his seminal fluid. And so this is evidence that the virus just simply doesn't go away, but rather it stays in the seminal fluid for a little while longer. The important thing, and I'm going to end with the Ebola story now, is that there's someone with Ebola, it is unlikely that they will ever be able to travel without assistance. And therefore, if they are so sick and they cannot travel without assistance, we therefore, the surveillance systems at the airports and seaports essentially will detect only people that are well. Somebody getting sick, it's really, it's going to be playing dice. Neither has there been a spread by mosquitoes or other insects. Okay, this is what I used to call my bread and butter, dengue, but it's no more than that. So chikungunya and dengue has emerged in the Caribbean region because of a number of factors. The first is the anthropological factor, which includes demographic changes and societal changes. What do we mean by that? We mean people leaving the rural environment and coming into the towns and cities for a better life. And who would blame them? But when they arrive, they put stress on the goods and services in the towns and cities, having problems with water supply and with disposal of waste. And these are the situations that actually create a suitable habitat and environment for dengue and chikungunya vectors, Aedes aegypti and Aedes albopictus, to actually flourish. So, we are also developing, and we are developing into different kinds of creatures. We are no longer people who would open our doors when people come to do their work, but rather keep the door closed because you're scared. And therefore, people are not allowed to walk into people's houses and do inspections and treatments. And I'm sure many of the inspectors that are here would know of this societal change. When in the past, people were quite open and welcome you to come and do the work. But now they shun you. The increase in land and sea transport, I think you have just seen enough of land and sea transportation. The failure of Aedes aegypti program due to a lack of political will. There are biological factors. There's insecticide resistance. There are infected vectors require longer feeding times. Changes in the size and vector potential. And very often people wonder, do they really have some changes? Well, we have found that Aedes aegypti no longer bite only during the day, but bite during the night as well. And as a result of that, you extend the biting cycle, you extend the transmission period. So it's very important that the work be continued and that the householders provide the support needed. And of course, there are different strains and new and different strains. And welcome to dengue 5, which is now found only in the monkeys. So the next wave could be dengue 5, but it's only restricted right now to the monkey population. It has not had a breakthrough into human population. Okay, chikungunya. with respect to chikungunya, we went through the transmission where they actually came from Europe into the Caribbean region. So you know all that already. There are two cycles for chikungunya. There is the urban cycle, which is here where people get infected, and people who provide the breeding source for Aedes aegypti mosquitoes, they get bitten and they transmit it to themselves, to their families, and their friends. So you can't expect the government or the ministries to do everything. People have to take personal responsibility. I often talk about Aedes aegypti and dengue control, like talking about dentistry. If you have a toothache and you don't brush your teeth and take care of them, you can't complain that the government didn't provide you with a toothbrush. I didn't brush your teeth for you. You didn't do it for yourself. So if you got a cavity, it's your fault, right? Because you know what to do. And if you don't do it, then you stand the consequences. And so this is the part of the problem. And this is the distribution of dengue, which everybody knows. It's along the equator. This is what the virus looks like. So when we put together chikungunya and dengue, we see that there are no bats or birds that are involved in the cycle. But humans are the amplifying host for chikungunya and dengue. But we also see that, like in 2000, the disease went into areas which had not previously had outbreaks. For example, in the United States, in Hawaii, and in some parts of Florida. So through these active movement of people and mosquitoes, transmission is taking place right now in new locations. So again, the role of travelers is quite clear. So the current dengue and chick situation in Trinidad, there are no figures. I've tried to get figures. There may be about 5,000 cases, but who knows? There are no number of dengue cases, we don't know. Maybe 1,000 cases, who knows? Vector control strategies. Focal, perifocal, for the people that are actually applying it to the breeding sites of the Aedes aegypti. They go around with trucks and spray, and that's when you close your windows rather than open your windows. Yes? Source reduction, when they ask you to take out your cans that fills with water, you take out mattresses, which do not hold any water. And so you remove garbage rather than the breeding site of the mosquito. And so therefore, health education. Well, I'm happy this is one of the few health education programs that will work, because why it works is that it sometimes gives the right information and the right ear is probably listening. So source reduction, do you know what source reduction is? It's the actual removal of the breeding sites. So why have all these programs been failing? We didn't get up yesterday and say the program not working. But what has been going on is that treatment strategies that people have read about in other countries, they seem to think it works there and you could bring it here and it will work. But we just found out that if the environment is not suitable, it will not work. Some people have a tendency to ignore a problem, and sometimes it goes away, and sometimes it persists, and then they do something about it. Some people consider the media as a rogue media. They are rogue because they do not get the necessary information. If you embrace the media at all points and you tell them exactly what is required, they cannot change the message. The message is clear. So the media should be used, and it's a very effective thing because education and health is an important dynamic that we need more of, which we need, and we need to really get the media involved in education programs. Using the same approach and expecting a different result. That was the definition of madness. The insecticides that have been used have been used for the last 35 to 40 years. Why aren't they using new strategies? As a result, after 30 years, the communities get fatigued. They're tired of the same people coming back, and therefore you would lose support. Some people are in complete denial. Or some people says that vector control helps. It helps, but it doesn't solve all the problems. Very often people consider a lack of political will. Some people we have advocating ineffective strategies like aerial spraying. Now, these are non-technical advisors because no technical advisor would make such a suggestion, given the fact that the mosquitoes are found in and around houses. And I'll provide evidence for that just now. Now, in 2012 and 2013, I warned in 3 different public lectures that there was no justification for aerial spraying. I don't care what people say. There was no evidence, scientific evidence for aerial spraying. Because it was ineffective, because of lack of penetration of insecticides into houses to kill the resting mosquitoes. It increased the risk of asthmatics and persons with respiratory illnesses. It had a negative impact on insecticides on pollinators, the butterflies, the bees, the birds. The negative impact on aquaria fish, piggeries, chicken farms, destruction of components of the ecosystem. We need oxygen to breathe. And the potential silent dawn and dusk, which is akin to Rachel Carson's Silent Spring. There are some parts of Trinidad right now that you do not hear songbirds in the morning. So what happens when evidence is not used to inform policy? The media reported that a regional corporation conducted aerial spraying of the forest and water courses recently for mosquito control. Chikungunya, dengue, they live in and around houses. Why are you spraying water courses? The report suggests that it needs to be continued. But where is the evidence that it's effective? Aedes aegypti breathes in clean, clear water in and around houses. What are the impacts? We don't ever see this one, but pollinators killed and will affect agricultural production in that particular area. Hives have been destroyed. So there'll be increase for people who like honey. There'll be an increase in honey cost. It's already expensive. The beehives already had a problem because there's a global disease that's spreading among beehives. Monkeys were killed. Birds were killed. So who is responsible? When you have non-technical advisors and giving advice, who is responsible for compensating farmers? Who can undo the damage to the ecosystem? How many asthmatics were affected? Is making profit the bottom line? And so we have to look at corporate Trinidad and Tobago and actually find out what is important. Now, we talk about dengue, and if you look at the slide from 1981 to that period there, There was the Aedes aegypti indices was next to zero. But as soon as the index, the mosquito density increased, you had dengue cases occurring. Let's look at it. This has been the pattern where we have had outbreaks. Here, we had a drop, an epidemic, and we had these epidemics in 10 and 11. I don't have the data for the rest. What do we see? We see the rainy season, the dry season, the wet season. This is not rocket science. This is simple making a graph. The rainy season starts, the mosquito indices start rising. The Breteau index is the mosquito index. And soon follows the dengue cases. This happens every year. If we use our intelligence, we could find, and these are the serotypes that are circulating. So what do we need to do to develop a control program? We need to understand the mosquito. We need to know the behavior of the mosquito. And we need to know the vulnerable life stages next. We need to know the human housing patterns and all of that. We need to know the environment and the transmission. So what is my proposal? What is my suggestion? You know, you can't be knocking everything down. You have to give some answers and some solutions to the problem. Well, my suggestion is to select methods based on knowledge of local vector biology and disease transmission patterns. Every physician in this room could tell you when the dengue season starts, because the patients start coming into their practice. And that could be used as an early warning system, please. Utilizing a range of intervention, often in combination and synergistically. So don't use one strategy. There are many strategies. Use them, and use them effectively. When one does not work, try another one. Collaborate with the health sectors and with public and private sectors that control breeding sites. Engage your local communities. Tell them you have a problem. Identify with the problem and find solutions with them. Use the public health regulatory system as the minister outlined. Rational use of insecticide. Good management practice. Don't ask your workers to do things that you would not do. If you cannot do it, don't tell them to do it. So every manager in vector control should be able to practice what they are asking workers to do. So we come to an intervention method. The sticky trap, for example, is one intervention method which has no labor to be associated with it, less expensive, and is selective and sensitive in collecting adult mosquitoes. It's simple: a black pot, a piece of sticky material, and some water and a few tablets of hay infusion. And the mosquitoes come there. Look at the results. You collected 2,286 adult mosquitoes in an urban area of St. Augustine. 5,900. Over 7,000 or 8,000 immatures. These are actually being removed from the environment. You have done nothing. You've just put this container out there, and it's working on its own. It's removing all these adult mosquitoes and immature mosquitoes. No labor. You just need to put it down. Pre-seasonal. Now, this is what I was talking about just now. We know the pattern of the rainy season and dry season. We know with the onset of the rains, you will have an increase in the mosquito index. We know with the onset of the rains, dengue will come. Can we not use that as a model? Okay, let's see what happens. What we did was we had a control area and a treatment area. Just before the onset of the rains, we implemented treatment. And what happened is that the population, as the rains came, there were no eggs, no mosquitoes present to actually renew transmission. So we had essentially controlled this, in this particular part of St. Joseph and Curep, for almost 11 weeks by just getting information from the Met Services. When do you anticipate the onset of the rainy season? 3-4 weeks, and you need a lag time of 4 weeks. So once you start putting down it and you start treating the containers, there are no adult mosquitoes to emerge when the rains fall, because the eggs will be flooded and the insecticides will kill it. Not rocket science. Simple. We also did some work and we found out that mosquitoes do not fly from the eastern side of highways to the western side of highways. They don't. Now, so, you know, we talk about aircraft, you think that's high tech, right? This is road tech. This is cars we're talking about now. So cars create that flight thrust that prevents the mosquito, and therefore we found dengue on this side of Charlie Village and Charlieville, and rather than on this side, because the mosquito could not fly across. So they were separating. Now, we thought, well, this is interesting. Well, let's see what happens if we look at roads and dengue. So we found out that dengue cases, we had none in first-class roads, which are the highways. In second-class roads, only 7%. But in third and fourth-class roads, this is the roads in Bel Air and in certain highfalutin areas, St. Joseph. I'm trying to remember some Palmis and places like that. They represent third and fourth class roads. So you know what happens? The mosquito can fly across the road and therefore infect you. So the data clearly showed that transportation routes are very, very important in disease transmission, with over 89% of the dengue cases occurring around the third and fourth class roads. So this is, next please. We also went on to find out, well, if these houses in the third and fourth class roads are infected with dengue and with the mosquito, we found out that in Mexico, they were starting to call some houses casa segura, or safe houses. And the reason why they were saying casa segura was safe house, because the same thing here, nobody were allowed to enter the premises, but these infected mosquitoes were living very happily 27 days after a dengue case was found in a particular home. So that means that mosquito actually left the room, went out and laid their eggs, came back in, and continued to transmit in that bedroom. So we also developed that this was a key premises. So this must be a key in transmission of the disease. And then we then looked at the containers, and these were then the key containers. These were the containers that were producing the mosquitoes that would transmit the disease. So this information, we developed the new Cardinal points surveillance system, where in the past, if you had a dengue case, you would do the entire block area. And this would take a lot of manpower, take a long time. You'll use, and if there are closed houses, you will have endless problems. But if you followed the cardinal points, with the positive house being in the middle, and you do the house to the east, to the west, to the north, and to the south, you were finding most of the breeding and most of the dengue cases, because the mosquitoes do not fly more than 100 meters. So why actually go and spray an entire block area when the mosquitoes cannot fly very far? So this then led us to the decision, well, where exactly are these mosquitoes living? So we did inspections in houses, and we actually found most of them in bedrooms. I would, if I was a mosquito, that would be the logical place, right? So the bedrooms, 81.9%, living room, 8.7%, kitchen, 6.1%, and 6%. So this is interesting, because if the mosquitoes, most of them are in your bedrooms, and why are you spraying outside? The evidence doesn't support this strategy. So, can you remember this strategy? It's called residual spraying. This is the strategy where you actually put down insecticide on walls, and they last for 2 weeks, probably 2 months. So when the mosquitoes in the bedroom rest on those walls, they die. Or you do the fogging inside houses rather than outside. And I mean, just yesterday in the newspapers, you saw someone in their control for chikungunya fogging outside a big blank wall, and they're fogging along the wall. Where is this fog going to get in? It hits the wall and bounces straight up in the air into the atmosphere. So is this just eye medicine that is telling you that, we're doing something? Is this placebo effect? So we have evidence of the feeding times of the mosquitoes. We know where they rest. We know where they lay eggs in the containers. We know before and after they lay eggs. We know what time the sugar feed. We know what time they rest after sugar feeding. We know where they rest inside the house, outside the houses. It should be relatively easy to develop control strategies. And this is just a composite of the actual behavior of times when the mosquitoes actually do what. So for the first time, we have a complete picture of the behavior of this 24 hours a day. And if you notice, these mosquitoes are only active for about 2 or 3 hours. And after they have gotten their blood meal, the rest of the time, they rest indoors or they rest on walls. So they don't fly. Why are they flying? Because they are full of blood. They need to get rid of excess fluid from the blood, which is called pre-diuresis and diuresis. And then they need to get the proteins into a form that they can actually then make eggs. So during this process, this mosquito is not flying about, taking a blood meal, but it's resting, it's finding a place that they can hide and go through this developmental process. And this developmental process takes as much as 58 to 62 hours, which is 2 to 3 days. So that mosquito will be, if it's taken and if it's in your room, it will be resting there. So they are sitting ducks to be killed. But you must use the appropriate strategy. So in order to develop other strategies, I've done some work in the Indian Ocean islands of Mauritius, Reunion, Seychelles, Madagascar and Sri Lanka. And we are developing some new strategies, which is called STI, which is sterile insect technique. This is rather environmentally friendly. It does not contaminate the food chain. The benefit, because they don't use any reservoirs, wild animals. It's really species specific. There's no threat to humans, and it's found so far to be quite effective. So there are a number of lessons that we have learned about these treatments in Southeast Asia. And I think it's important that we re-emphasize the political will, the media, and public support. But one of the missing links in this whole human activity is the human acceptance of the programs. What are the levels of communities' knowledge, attitudes, and practice and beliefs? Are the communities really supporting a vector control program? Because without them, we can't have any support. And without their support, our programs would fail. Do we know who the community leaders are? I mean, in this room, I know who the community leaders are. Do we understand the demographics? Do we understand who does what? You don't want to go and spray somebody's house in October, knowing that Diwali is going to be very close by, and the people who are of that religion scrub their walls every time there's Diwali. So that'll be a waste of time. So culturally, you need to know demographics. You need to know the community that you're dealing with. You wouldn't want to go and do those kinds of residual spraying at Christmas time for the Christians or during Eid for the Muslims. So you have to be really in tune with what is happening in your communities. So you develop community programs and practices so that you could then align your program to suit the different communities that you are encountering. What are the housing patterns? Is it a block plan, a city, or is it along the road? Because along the road, the strategy would be completely different if it's a block plan system. What is the weather? I mean, we talk about climate change. What's the weather pattern like? Is it predictable? It's not predictable. The mayor indicated that I went to Naparima College. Yes, the rains always fell from 12 o'clock to 1:30, 2 o'clock. It usually stopped right on time for us to go home. Correct, David? It will always stop. Is that the same practice today? I don't know. So we need to be observant as people in our communities. So we need to really have an integration of three different parts: the weather, vectors, human data. We need to understand the predictiveness of the weather. We need to know the citizen reporting symptoms, the clinicians doing their early warning systems, the sentinels, physicians, the breeding sites. We need to have civic engagement, all of these. And then we can do the health communication, and which would then lead to the targeting of different communities. Now, I showed the model about how policies and decisions are made. Well, the way we teach it at the university is that evidence informs policy, planning, and implementation. But I was sadly told the other day, the reality is different. So policy is really a political policy. And I am not sure that I am competent enough to discuss that any further. But what I could say is that this evening we have discussed the role of transportation in the transmission of disease at the local, regional, and international arenas. And we have seen that without evidence, decisions cannot be made. But with hard data and evidence from sound scientific research, it can really inform policy for planning and for implementation. So with that, I know people have been here for a long time. I thank you all.